When I was teaching on the side angle side day and the side side day, we actually filled this out. And then I forgot to refer to it again. So angle side angle is two angles and the side that is in between. So let's go ahead and label this angle and this angle. And we can label this angle and this angle. And then it has to be the side that's in between them. Has to be. The side in between them. So angle, two angles with the side in between them. Okay. And then angle, angle, side is, again, you have two angles. And you have a side that is not in between them. So two angles and a side that is not in between them. Okay. For hypotenuse leg, you have to start with a right triangle. You have to start with a right triangle. So if that is not clear from these instructions, it says any right triangle, but I'm going to go ahead and write it here. Start with a right triangle. You might say, Miss Rice, but it says that already. And if it's clear to you that it says that already, then you don't need to write it. But I'm going to write start with a right triangle. Because you have to have that first. Then after you have that, as long as you have a leg that is congruent and then a hypotenuse that is congruent, then you can do a hypotenuse leg. All right, what is the one that does not work? Angle, side, side. We don't want none of that in this class. No, ma'am. No, sir. You can do SSA if you want to be more school appropriate. This is like the only time you get permission to like curse on your sheet, though. Do you feel somewhat empowered if you write angle, side, side? Did you guys like that I put it on your quiz? There was one time I was teaching much like this, and I had just written it real big, and I had not yet circled it and crossed through it. I just wrote angle, side, side very large on my board, and a student snapped a picture of me teaching. So all it is a picture of me teaching, and then it says angle, side, side real big behind me. That is in my 13 years of teaching, that is the only picture I have, the only picture, one, of me teaching, like candid teaching, not posed, is me, like this, with angle, side, side written very large behind me. I sent it to my mom. I said, Mom, look, I'm teaching. And she's like, what is happening in that class? And I said, don't worry, they're learning. She's very proud. All right, next page. So, some of you guys were like, Miss Rice, can we have some of the like cheat sheet stuff, or can we have something for all those parallel lines and transversals? And I said the only thing I was going to give you is these two sheets. So let's go ahead and draw some pictures for these alternate interior angles, alternate exterior angles, and let's write some stuff about the congruent and supplementary. It's in here, it just wasn't in here maybe in a way where you guys thought that it was in here, or maybe you didn't take the time to read it and realize that it actually is on this sheet, okay? So let's go ahead and draw pictures of all of these next to the definitions so that we actually know that those definitions are on this sheet, okay? Alternate interior angles, let's draw a little picture. So we have two parallel lines and a transversal. And what do alternate interior angles look like? Alternate interior angles, what do they look like? They look like alternate interior angles. They're between the parallel lines, right? Between the parallel lines on opposite sides. And they are the exact same measurement. My picture is so tiny, maybe I could draw it a little bit bigger. Or the other thing you could do is you could do one big picture and put numbers. Should we do that instead? Do one big picture and just put numbers? You guys can do it however you want. I'm going to do one big picture and put numbers. If you guys want to do a smaller picture for each one, that is fine. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. And so for alternate interior angles, I'm going to say angle 3 is congruent to angle 6. That's a little bit easier than doing separate small pictures for each one. Okay. So angle 3 is congruent to angle 6. Okay. And in the definition, it did say they are congruent. Okay. Alternate exterior angles. In my drawing, which one are alternate exterior? 8 and 1. Angle 1 and 8. Angle 2 and 7 would be alternate exterior. These are congruent. So I'm going to go over in the definition. I'm going to circle the word congruent. Same side interior. 4 and 6. So I'm going to write angle 4. I'm not going to write that they're congruent. I'm going to say angle 4 and angle 6 are supplementary. And I'm going to circle the word supplementary in the definition. You can say add to 180. And yeah, you could actually put this here too, because we know when we solve them, we could say measure of angle 3 equals measure of angle 6. That's what that means. This means that measure of angle 4 plus measure of angle 6 equals 180. That's what supplementary means. Okay. Same side exterior. Which ones are same side exterior? 1 and 7 or 2 and 8? Angle 1 and angle 7 are supplementary. Okay. What would the corresponding angles be? 1 and 5. Angle 1 is congruent to angle 5. All right, which ones are a linear pair? 5 and 6. Angle 5 and angle 6 are supplementary. Okay. And then which ones are vertical angles? 1 and 4. Angle 1 is congruent to angle 4. Okay. So I went ahead and I circled those keywords in each of those definitions. Now over here, I'm not going to include linear pair. I'm not going to include vertical angles. I'm going to stop right here. Oh, sorry. And I'm going to write converse of these can prove that lines are parallel. Okay, so that kind of gets all those angle relationships in there if we were to brain fart on a test. Does that make you feel a little bit more comfortable about if we were to forget those? Okay, so I think at this point we've got everything. Can you guys think of maybe one of the reasons? Remember when we did the proofs, we did statement, we did reason. Is there a reason that we have used on a proof that does not show up on this list? Yesterday we did use definition of a right triangle. Was a triangle that had a 90-degree angle in it. We could add that to the list. Would that be good? So I'm going to add it right in here. I know there's lines on the back, but you can put it on the back if you want. I'm going to put it right here just because it's near where the right angles is, which is where we typically we would do right angles first, then we would typically use right triangle. So I'm going to put it right here just because that's probably where I'm going to use it. I'm going to use it in that same context. So I'm going to say definition of right triangle. And then I'm going to say a triangle that has a 90-degree angle. In it. Okay. Is there anything else that we've used? Yeah. There's no definition of midpoint. We use that all the time. Let's add that. Okay, definition of midpoint. That's crazy. A definition of midpoint is not on there. Okay, a midpoint. Oh, a midpoint cuts a line segment into two equal parts. Okay. Anything else we should add on there? Yeah. Yeah. Let me zoom. Ta-da. Okay. All right, you guys ready? Don't worry, I wasn't recording, so I'm not going to sick Officer Huffman on you. Thank goodness. He would have had to take that very seriously. All right. Are you guys ready? We are going to have some flashbacks to dilations today. Are you guys ready to have some flashbacks to dilations? All right. Similar polygons are polygons with the same shape, but a different size. Same shape, but a different size. They are similar if the corresponding angles are congruent. And the corresponding sides are proportional. So the sides are not congruent, but they are proportional. Let me zoom a smidge. Smidge. There we go. We're going back to your favorite thing. The ratio of corresponding sides is called the scale factor. Remember that? Yes. From dilations. Does that sound familiar? Scale factor? What a great time, Miss Rice. I'm not at all triggered. Twice in one day. Scale factor. So this is just like dilations, but we're not talking about coordinates anymore. We're not talking about that. We're not talking about transformations. We're talking about polygons and similar figures, but it's the same idea. Truly the same idea as dilations were. So that means the angles stay the same, the side lengths change, but they are proportional to each other. That's what makes a similar figure. All right. If polygons are similar, then their perimeters are also proportional. All right. So, what is the scale factor of ABC to DEF? So here's how we're going to write it. You have to be very careful here because the order matters, because you'll notice the next question is DEF to ABC. See how they switched it? So this is you have to be very careful in your notes on this because it switches depending on the order. Okay, so here's what I want you to write. This is very important because this is going to confuse you later if you don't have this in your notes. Okay, so we're going to write ABC, triangle ABC, over triangle DEF. When they say triangle ABC to DEF, when they write it like that, they mean put ABC on the top of the fraction, put DEF on the bottom of the fraction. Okay? Now they did the labels for you. They showed you A corresponds to D, B corresponds to E, C corresponds to F. So let's pick two sides that correspond to each other. Which sides do you want to pick? Okay, so AB is 8, DE is 12, so we're going to say 8 over 12. And what does that simplify to be? Let's keep it as a fraction. 3 over 2. So they each divide by, wait, not 3 over 2, 2 over 3. By 4, so it's 2 over 3. Perfect. So the scale factor is 2 to 3. Does that make sense? 2 to 3 is the scale factor, okay? They could also write this as 2 to 3. Same answer, they could write it as 2 to 3. Do you guys see the difference? You can write it as 2 over 3, and you can write it as kind of a ratio like that, 2 to 3. 2 to 3, 2 to 3. Okay? Now, they could also say triangle DEF over triangle ABC, and you can use the same sides, 12 over 8, 3 over 2. We're comparing the same triangles, but depending the order that you phrase it, it's going to change how you relate the scale factor. Does that make sense? So here we'd say, oh, 3 to 2. So the order matters. And the reason it's not as straightforward as when we did dilations is because we don't have one triangle that's clearly labeled as the pre-image and one triangle that's clearly labeled as the image. We're just saying we have two triangles that are equal to each other. We're saying there's not one that came first, one that came second. They both came at the same time. They're similar to each other. And so the way that we phrase it tells us which one is going to come first, which one's going to come second, okay? So the way you phrase it matters. Does that make sense? Okay? So you're going to have to pay very close attention to that. If you have colors in front of you, I would box that, star that, do something to that, because this is where students are going to make subtle mistakes, is by accidentally putting the wrong one on top. Okay? All right. Now it says, say that again? I would put a box around here, just to keep in mind that the order matters. Order matters. So this whole thing is what I would put a box around. So 3 to 2, 2 to 3. Those answers are very different from each other. 2/3, 3/2, those are not the same decimal at all. 0.666, 1.5, those are two very different decimals. But they both correctly assess the situation depending on how you phrase it. So it's not the same with dilations where the labels in dilations, the label of the triangles clearly told us which one to do first. In similar triangles, it depends on how they phrase it. It can switch back and forth depending on how they phrase it. And that makes it a little bit more vague, unless we're being careful. So this is where we're getting back to that mathematicians are type A personalities. They're very precise. And so we're getting back to that precision piece today. Okay, now it says let's do the ratio of the perimeters. So go ahead and grab your calculators. Let's find the perimeter of DEF. Ooh, somebody did that real quick. They were ready. Boom, 48. Boom. Ooh, 32. Okay, so let's go ahead and do the ratio of the perimeters. So we've got triangle DEF to triangle ABC, which is 48 over 32. And if you reduce that, what can you divide both of those numbers by to reduce it? 16. If you reduce it, what do you get? 3 over 2. So this is what they were saying, is that their perimeters have the same proportionality that the sides do. If the sides have a proportion of 3 to 2, the perimeters have a proportion of 3 to 2 as well. Same. Okay? Not the same with the area, because the sides have a unit of just units. The area has a unit of units squared. And so that's different. Yeah. Remember with dilations, what we found there? So they should have a proportionality of 9/4 instead of 3/2, because it should be squared. Does that make sense? Okay. All right. Similarity statements. All right, so the symbol for similar is not congruent. Congruent, you do a squiggly over an equal sign because they are equal to each other. Here we just do squiggly. All right, just similar, not equal to. All right, so write a similarity statement for the triangles above. So all you do is you say triangle ABC is similar to triangle DEF. That's the similarity statement. She does the same sarcastic voice that I do. It gets like, you know, a little grumbly, little. I'm gonna tell her that you said she was like a chihuahua, and then I'm just gonna see what she does.
Whole name?
Yep. I'm gonna be like, Pammy Sue. Pammy Sue, there's a freshman in my class that said you were a chihuahua. Get him, Pammy. All right. So this is going to feel pretty similar to triangles when we start off, okay? When they give you that similarity statement, you know that the angles are congruent to each other. You know the angles are congruent. So when they say JKL, we're going to do JKL just like we did last time. Does this feel a little bit deja vu-like? We've been here before. JKL and then PMN. So we have angle J, angle K, angle L, and which angle is angle J congruent to? Angle J is congruent to angle P. What is K congruent to? M. What is L congruent to? N. Okay. Now, if we were dealing with triangles, we would say the sides are congruent. Sorry, we're dealing with triangles. If we were dealing with congruent triangles, we would now be listing the sides that were congruent. We are not dealing with congruent triangles. We are dealing with similar triangles. So now we're going to say the sides that are proportional to each other. Okay? And so the proportions are going to be a triangle over another triangle. Does that make sense? One side is proportional to another. So I'm going to do 1 to 2. So JK, I should not be labeling it like this though, because that makes it sound like they're the same. So JK is proportional to PM. And that proportion is going to be the same as KL to MN. So I did the 1 to 2 side is proportional to the 1 to 2 side. I did the 2 to 3 side is proportional to the 2 to 3 side. And now I'm going to do the 1 to 3 side, JL, is proportional to the 1 to 3 side, PN. No, because we're talking about the lengths of the sides. The lengths of the sides are proportional to each other. So when you talk about the lengths of the sides, you do not have to put the little line above. That was a really good question. So typically we put the line above when we're saying the two sides are congruent to each other. Now I'm not talking about congruence. I'm saying that the measurements of the sides are proportional to each other, and so I drop the little line that's above the letters. JK is proportional to PM, so I'm talking about the actual lengths, and they are not congruent to each other. They are proportional to each other, and I'm specifically referring to their lengths. Okay? That's a really good clarification. So I'm going to write that in my notes. No line above line segments because I'm referring to their lengths. No line above the line segments, no line above JK, no line above PM, no line above KL, no line above any of them, because I am referring to their lengths for all of these. The length of JK is proportional to the length of PM, but the segments themselves are not congruent. Okay. How are your brains feeling? Fine? Good? All right, let's turn the page. All right, here we have X, Y, Z. So I've got X, Y, Z is congruent to R, I already labeled, Y, and then S. Now, we have something interesting happening. I've got two angles right here that are the same and two angles that are right there that are the same. And what conclusion can you make about RS and XZ? They're parallel. How do you know? Corresponding angles, but not corresponding angles, but you're close. Converse, because converse of corresponding angles. That is not part of these notes. I just thought it was something interesting that showed up in the notes. So it was not like, oh, that was something we were supposed to fill out, but it is interesting that it showed up. So those happen to be parallel, because we got corresponding angles here and corresponding angles there that are congruent. Okay, so if we look at this, we have angle X, angle Y, angle Z. And what angle is X congruent to? R. What angle is Y congruent to? Y. What angle is Z congruent to? S. Okay. I want you guys to take a moment and write out your proportions. So I was very careful when I did mine to make sure that the big triangle was on top for all three of them, and that the smaller triangle was on bottom for all three. And it doesn't matter if you did the big triangle on top or on bottom, but it does matter that you're consistent. So yours don't have to match mine perfectly as long as you're consistent when you do it, as long as your letters match up the way they're supposed to match up. So my Y is always in the same spot, my X and my R always match up, my Z and my S always match up. Okay, so I'm going to leave number 3 for you to finish. We're going to move on to number 4. All right, it tells you that you have the figures below are similar with a scale factor of 2 to 3, and they want you to find the value of x. So they said 2 to 3, so this is your 2 to 3. You can tell, there's 2 ways you can tell. One way you can tell which one is 2 and which one is 3 is just because this one is smaller, this one is bigger. You can also tell because this one comes first, this one comes second, and they did the same order that they did in the sentence, okay? So I'm going to write this, I'm going to say 2 to 3, I'm going to write this as a proportion. 2 to 3 equals 42 over x. See how I wrote that as a proportion equation? One proportion equals another proportion, okay? Now, does anyone remember how to solve an equation when I have a fraction equals a fraction? Cross multiply. So we have 2 times x is 2x. And we need our calculators for this. We've got 3 times 42, 126. Okay, and you should actually write 3 times 42 just in case you brain fart later because these are your notes. So it's good to have all the math written down in your notes. And then what is our answer? 63. Okay. All right, this one's pretty simple. So let's go ahead and just do 5 as well. So it says 6 to 5. Same thing, we've got one that's visually bigger than the other, so we can kind of guess what they are, but they still put them in order. So we've got 6 to 5. So we're going to go 6 over 5 equals x over 28. So we're being consistent. Big over smaller equals big over smaller. See how I'm being consistent? Big over small equals big over small. And then I'm going to cross multiply. So 5x equals 6 times 28. And what is 6 times 28? Okay. Aren't you guys glad Jack is here? He can just be calculator this period. And this one ends up being a decimal. And what decimal do we get? 33.6. Okay. All right. So for problems like that, it's pretty easy to see what sides correspond to each other because there's only one side given. So you're like, well, they have to correspond because they didn't tell us any other information. The problems like the next one, it's a little bit more difficult because they actually labeled multiple things. And this is where students usually start to get confused. So this is where the similarity statement helps us. So we're going to treat this just like we treated those congruent triangle problems back at the beginning of the unit. We're going to label which angles are the same. A, B, C, D, E, F. And that's going to help us figure out which sides correspond to each other, okay? So again, the order matters. So it doesn't really matter which one you put on top and which one you put on bottom, as long as you are consistent. What I typically do is I do left on top, right on bottom. That is my habit, okay? So again, it doesn't matter as long as you're consistent. So this is 1 to 2. So I'm going to do x on top. And then for 1 to 2, 25, I'm going to do 25 on bottom. And then 28 is the 2 to 3 side, so I'm going to do 28 on top. And then the 2 to 3 side is 20, I'm going to do 20 on bottom. Do you see how I figured out what goes on top, what goes on bottom? So when I labeled the angles, it became pretty clear what side corresponded to what side. It wasn't as easy until I drew in those labels. So X corresponds to 25, 28 corresponds to 12. And now I can go ahead and cross multiply. So I have 20x equals 25 times 28. 20x equals, Jack, where's our calculator? 700. Jack, somebody beat you. Oh no! 700 divided by 20. X is 35. Okay. All right. So number 7, I'm going to leave for you guys to do. So I usually do 1, 2, 3, but honestly, it doesn't matter. I usually do 1 for the first one, 2, and then 3, 1, 2, 3. As long as you're consistent, it doesn't matter. Okay. Let's go ahead and turn to the next page. So there's a little bit of a strategy with problems like number 8. So again, I'm going to start off by labeling my angles, D, E, F, H, J, G. And what I want to do first, because we have 2 variables, what I want to do first is I want to figure out which sides have no variable at all. Which sides are a number on one triangle and a number on the other triangle. So can you guys figure it out? Which one is a number and a number? So this one, the 1 to 2 side is 15, and the 1 to 2 side is 9. We are going to use that proportion to solve for the x, and we're going to use that proportion to solve for y, because that proportion doesn't have a variable with it, so it's important for both variables to help us solve, okay? So I'm going to start by doing 9 over 15. Does that make sense? Because it does not have a variable, okay? So I'm going to do 9 over 15, and I'm going to do this for both problems, okay? So I'm going to write this twice. So this is a good strategy when you're solving for 2 different variables in a problem, is to figure out which sides do not have a variable in them, okay? Now the x is 1 to 3, so I'm going to figure out which side has 1 to 3 on the other triangle. It's this one. So I did small triangle over big triangle. I did 9 over 15. So for the x, I'm going to do equals 12 over x. And then for the y, that's the 2 to 3 side, 2 to 3, then I can do 14 over y. So that way, I'm not setting up a proportion where I accidentally have 2 variables in the same problem. Okay? And now I can go ahead and cross multiply. And for y, you do get a decimal. Okay. Oops, I solved it without you guys. How are you guys doing with getting those solutions? Are we doing okay? Yes? Okay. I can always tell when you guys are comfortable because you guys, your eyes, like, I can tell when I lose you and you start working ahead. You guys are like, I got it, I'm done with you. Miss Rice, I don't need you anymore. Bye. And I'm like, okay, fine. I won't. I'll just give you some pointers. Yep, see, case in point. That's what you're doing right now. I feel ditched. How do you guys feel looking at number 10 with the x plus 6 and the x plus 3? Should we look at that one? Number 9 is pretty similar to number 8, even though the two triangles are touching each other. So number 9 and 8 are very close, but number 10 is different. Would you guys like to do number 10, or are you going to continue to ditch me? You would like help on 9? We can look at 9. What are the two sides that don't have a variable on number 9? The 1 to 2 side, the 40 and the 16. So we can do big over little, big over little. X is on the 2 to 3 side, and the 2 to 3 side here is 14. So x over 14. 45 is the 1 to 3 side, y is the 1 to 3 side. 45 over y. All right, let's look at number 10. So I'm going to leave number 9 for you guys to finish. Let's look at number 10. So AGM. So 1, 2, 3. KXD. 1, 2, 3. Okay. Now, this one, we don't have to look for a side that only has numbers that correlates because even though there's two sides with variables, they're the same variable. So it's okay if both have a variable because we can still use it to solve. So I'm going to do left triangle over right triangle. The 1 to 2 side is 32. The 1 to 2 side is x plus 3. The 2 to 3 side is 36. The 2 to 3 side is x plus 6. So 1 to 2, 1 to 2, 2 to 3, 2 to 3. All right. Are we comfortable with how I set that up? We can see how I did the corresponding sides. Good? Okay. So what step am I at now? Cross multiply. And this cross multiplication is going to involve parentheses. So 32 times x plus 6, 36 times x plus 3. Because we're multiplying one term times two terms. So to make sure we do that correctly, we have to have parentheses. So then how do I do that? Mm-hmm. $32 times 6. Mm-hmm. So we're getting our x's to one side. And getting the numbers to the other side. So 84 equals 4x. And then what are you guys getting for x? 21 equals x. It's a sad day when your students don't even need you. All right. So I'm going to let you guys finish 11 and 12. Okay. The plan is you guys are going to finish the problems and these notes. And then I have another worksheet for you. Ta-da. And I'm going to pick up the booklets. I'm going to finish an answer key so you can check your work as you go. Sound good?